My name is Jake Marcinko. I'm a Senior Standards Manager for the PCI Security Standards Council. I chair the Council's Software Security Working Group, and today I'm here to talk a little bit about BOMs. Not these kinds of bombs, but these. BOM, or a bill of materials. Now, how many folks here have heard of a software bill of materials? Everyone in here? No? So for the few of you who don't know what a software bill of materials is, it's generally they're generally attributed to BOMs in general, are generally attributed to software as a way of describing the software composition in a machine-readable format, usually either in JSON or XML. But there are so many more use cases for bills of material that we'll get into in a little bit, besides software. So at least in the United States, much of the talk about software bill of materials is thanks to this document here, the Executive Order on Improving the Nation's Cybersecurity. This was released by the U.S. government in 2021. It's also affectionately known as EO 14028. And this was really in response to the SolarWinds attack that I'm sure everyone here heard about, that caused a number of different government and commercial organizations worldwide quite a bit of a headache. And it includes a clause buried much further down in this document that requires software providers to provide their customers or a purchaser a software bill of materials for each product. Now, the concept of a software bill of materials, or SBOM as we'll call them for the rest of today's session, isn't new. It's been around since 2010. When the SPDX specification was first created, and we'll talk about the specifications in a minute. And other entities besides the U.S. government now are looking to kind of follow suit and adopt similar legislation, including the EU Cyber Resilience Act, which is set to go, or CRA, which is set to go into effect in 2027. Now, for those of you who are familiar with the PCI Secure Software Standard, since 2022, we have also required at least vendors of web software products to produce a bill of materials for their software. And for those of you who participate in this program, we will be making this requirement, we're going to expand the scope of this requirement to not just web software, but any software product that is going through an evaluation to the standard when we do the V2 updates, which we're anticipating for publication in 2025, this will be a requirement for all software. Now, there are really two predominant formats used for creating software bill of materials. There's SPDX, which I mentioned before, which stands for System Package Data Exchange. And this specification is maintained by the Linux Foundation. And then the other one that we'll spend a little bit more time talking about today is Cyclone DX, and that is maintained by the OWASP community. Now, again, each of them has their pros and cons, but we're going to focus the rest of today's discussion a little bit more on Cyclone DX because of its added extensibility beyond just software bill of materials. So there are a lot of different open source and commercial tools available now to help organizations produce software bill of materials. Some of them are capable of auto-generating them, such as when you do your binary compilations. However, some of them need to be manually created too, or some aspects of it need to be manually created. And this is really due to the complex nature of modern software today. However, this is an area that there's been a lot of and continued growth and improvement. So as time goes on, there should be more and more solutions out there that are capable of generating this automatically. Now, again, you've heard me kind of refer to BOMs and SBOMs, and this is really intentional because an SBOM is specific to software. But like I said, there are so many other use cases or so many things that bills of materials can be used to describe. So let's look at a few of these. So this is a graphic from the Cyclone DX website, and it shows all the several different use cases that this specification can support. We already talked a little bit about software bill of materials. Now, they describe the inventory of software components that comprise a given piece of software and the dependency relationships between them. There are also SaaS BOMs, or software as a service bill of materials. Now, these can describe the different services, endpoints, data flows, and even the data classifications for cloud native applications. We also have HBOMs, not hydrogen bombs, but hardware bill of materials. And they can describe the inventory of the hardware components for things like IoT, integrated circuitry, other types of embedded devices. There are also ML BOMs, or machine learning bills of materials, that describe the machine learning models and data sets used. And it can also help organizations address security, privacy, safety, and other ethical concerns regarding the use of these models. There are even CBOMs, or cryptography bills of material. They describe the cryptographic assets and their dependencies. Now, one of the really cool things about Cyclone DX is that you can combine and nest different types of BOMs together. So if you have an application that might have an underlying component or even a hardware component, all of this can be described either in one document or a series of documents that are then linked together. And it's really good because it can provide a full stack inventory of all software components, runtime environments, configurations, cryptographic assets, and additional dependencies for a given implementation. And this is really achieved through the deep linking capabilities of the Cyclone DX specification. As I mentioned, they can be either nested within the or referenced externally to separate documents. And this allows separation between different bills of materials that from ones that might change a lot more frequently, that undergo a lot of updates, such as the software aspect of it, versus the hardware component of a given implementation that probably isn't going to really change all that much over time. So in addition to describing the composition of software and a broader implementation, there's some other use cases that are really particularly intriguing for us at the Council. The Cyclone specification can also describe standards, as well as it supports the use of attestations. So for those of you who are familiar, think about the ROV or the ROC. Right now, that's a paper document or a document that's in PDF form. This would enable us to potentially convert that, or not the ROC, I'm thinking the AOV. We could convert that AOV from a PDF-based document to a JSON or an XML-based document that could then get ingested in a GRC system. So for all of you folks, or particularly the QSAs in the audience, who have been asking the Council for years to allow you to customize the ROC or the AOV or AOC documents, this would really help facilitate that in a much easier way than what we currently support. So I mentioned the standards capability, and we'll look at some examples here in a second. The Cyclone DX specification allows you to articulate the actual security requirements within a given standard in a machine-readable format. So this is actually a prototype of the currently published Secure SLC standard version 1.1 in JSON format. And if you look at the top, you have obviously the BOM format information, the Cyclone DX, the specification version. It has a unique GUID up there and timestamp. But then as you kind of scroll down, you see under definitions, you see standards. And this is really where the actual requirements get specified. So you have here on this line, which is line 15, that's the first requirement. Then you have nested requirements underneath here. And it really allows you to articulate an entire standard in this format. And again, the use case really is for GRC tools, automated, and for the QSAs really trying to, when a new version of the standard gets published, they can now more quickly, or theoretically more quickly, update their systems to the latest version. It even allows nesting, facilitates requirement nesting, like I showed you here, which obviously for standards like DSS and software, we have a lot of requirement nesting. So it really is a kind of an interesting use case. So why would you want a standard in a machine-readable format? Well, first, as I mentioned, it supports the use and updates of GRC tools and systems. It makes documents a lot easier to search and conduct a more detailed change analysis from version to version of the same standard. It simplifies updates to GRC and other systems, when a new standard is published. And for us, for PCI, it really helps us to minimize errors across related documents. So the process for us right now, going from the standard to the ROC, for example, we're doing a lot of cutting and pasting because or duplicating information. This would potentially go away. Now, I also mentioned the attestation capability of the standards, and this really allows an entity and an assessor to make assertions about an entity's compliance with a given requirement or set of requirements. So here again is another snippet in JSON format, and we're going to look really at the first 16 lines. So I'll provide a slightly larger view here. So again, the schema, BOM format, and spec version, that lets us know the document and the specification that's being used. The serial number and version tags let us assign a unique ID and version to this particular document. And then you have the declarations tab, which is where we get into the meat of the attestations. Here it allows the assessor to identify themselves, so who's the assessor that conducted this assessment, and whether or not this is a third party or an entity conducting a self-assessment. Now we're going to drop down a little bit into the document and look at the attestation section. This is where we find where the assessed entity and the assessor specify their assertions and findings. So again, kind of a zoom up here. Here's where a lot of times, and we're not going to display this because this obviously is a rather large document, but at least at the top section, they, things like requirements, claims, the assessors, these are references to other sections deeper down in the document. So I just wanted to show, you see where the assessor on the far side of the screen, that actually references this part of the document where more additional information would be specified. So again, the assessor has identified themselves. They do that by referencing the same name value pair specified in the section we looked at previously. Then they would reference the requirement to which the assessed entity is making a compliance claim. And you can see that over there on the left. If we were referencing our SSLC prototype that we looked at earlier, this would say PCI SSC SSLC-1.11 instead of just requirement 1. This is, again, just a mock-up. And then finally, they would reference the claim that they're making about the referenced requirements. So this would point to another area in the document where more detail is provided. Oh, sorry. The other thing that's really cool about this is that you get down into so this is the claims section, where it allows the assessor to also make a counterclaim. So if an assessed entity makes a claim about a particular assertion about a particular requirement, this provides the assessor an opportunity to actually provide a counterclaim, and then also allows them to provide. See here, this is a slightly different deck than what we had. It allows them to provide a confidence score. So how confident is the assessor in their findings? A value of 1 means they're 100% confident. A 0.8 would be that they're 80% confident in their findings, and so on and so forth. They could also provide rationale. Now this is a short version here, but they could articulate their entire rationale for their conformity or their confidence score. They can also And then at the bottom here, they can actually also then sign the document. So they can make all their assertions, the claims and counterclaims, and then sign the document. Again, the nice thing is that you could actually do this on a requirement by requirement basis. So an organization could sign their findings for every single requirement, which is really a unique feature or a nice feature of this. So again, to kind of start to wrap up, there are really many benefits to the potential use of electronic attestations, such as those provided by CycloneDX. We could reduce reliance on Word and PDF versions for all reporting documentation, including both the RAWs and the ROCs, as well as the AOVs and AOCs. It enables customization of client-facing documents while still adhering to PCI SSC requirements for report submissions. It allows information within these documents to be updated and appended more easily. It would potentially get rid of the whole redlining a ROC to submit a change. And it would also enable individual attestations to be signed, not just the whole document. You could assign them at a requirement by requirement level. Now, despite these benefits, there are also some challenges. Not all PCI SSC standards can easily be ported to machine-readable formats. For instance, we have documents that have a lot of tables in them, nesting requirements, bulleted requirements. Those types of documents or those types of requirements, they don't really lend too well to converting them to JSON formats. So in order to take something like DSS, it would require a pretty significant revision in order to convert that to a machine-readable version. We've also not standardized on a particular approach or schema. So for instance, we've been focusing on CycloneDX today as one potential method. There are other methods like using Markdown, converting a document into Markdown. But again, pros and cons to each. Trying to recreate tables and Markdown is not a fun exercise. So we're still working through what's the right approach for this. And again, to be fair, converting all of our standards to machine-readable versions, is not really a priority for us at the moment. Now, having said that, in the secure software program, secure software and secure SLC standards, we are looking to pilot machine-readable versions for the next revision that's is planning to be published in 2025. So be on the lookout for that. And for more information on these specifications, you can go to the two specification websites, SPDX website and then the CycloneDX website. And then with that, thank you for your time today. I appreciate it.